Derive expression for magnetic field at any point on the axis of circular coil. So consider a circular coil with center O, radius R, carrying current I as shown in the figure. Let P be a point at a distance x on the axis of coil. Any writing part we have done or only diagram we have
So we had written here.
Written till
dB1
rectangle
can be
component.
resolved into two components, dB1 sin and dB1 cos.
Yes,
That
sir.
much clear है. Okay, ठीक है. अभी खाली उधर तक पूरा explain कर देता हूँ. Consider a circular coil with center O, radius R, carrying current I as shown in the figure. Let P be a point at distance x from center O on the axis of coil. Let dl be the elemental length at point P. Drop Pc. Let Pc equal to R. Magnetic induction at point P due to elemental length dl is given by dB1 equals to mu naught 4 pi upon is given by dB1 mu naught upon 4 pi I dl sin 90 upon R square. It can be resolved into two components, dB1 cos phi and dB1 sin phi. This much we have written in the last class. Okay, correct ना?
Yes, sir.
अभी इसके बाद बड़ा पार्ट elemental length dl at diametrically opposite point D produces magnetic induction dB2 at point P given by mu naught upon 4 pi I dl sin 90 upon R square because it is just mirror image of it. dB2 can also be resolved into two components, dB2 cos phi and dB2 sin phi. These two are same or different in magnitude. Just check what you can see. Are they same or different?
Same. Same.
So dB1 cos and dB2 cos, they are same. एक ऊपर एक नीचे. Result will be zero, ना?
Yes.
Now write further whatever you have written beyond that. Consider elemental length dl at diametrically opposite point D. The magnetic field at P due to dl at D is given by dB2 equals to mu naught I dl sin 90 upon 4 pi R square. dB2 is mu naught I dl upon 4 pi R square. It is directed as shown. It can also be resolved into two rectangular components dB1 cos phi and dB2 sin phi, as dB1 sin phi, dB1 cos phi and dB2 cos phi are equal and opposite, and they cancel each other. Tirtha, is it raining, Tirtha? Hello, Tirtha?
Yes, sir.
Is it raining? Because of that you are late?
Yeah, there was a power cut, so I couldn't
Yeah,
connect.
I thought you were coming by train and carrying umbrella and all, so you are late.
No, no.
Okay. Can you clear this out?
Yes.
Therefore, resultant magnetic field at P, dB. dB मतलब छोटा टुकड़ा से लिया ना, इसलिए dB equals to dB1 sin phi plus dB2 sin phi. They are in same direction. But dB1 is same as dB2. So can I say dB will be 2 times dB1 sin phi. dB1 is mu naught IDL upon 4 pi r square. Can you see the figure and tell me what is sin phi? Any of you can tell what is sin phi? Can I say opposite side r upon x? Sorry, r upon r, opposite upon hypotenuse? Yes, correct or not?
Yes, sir.
Yes, sir.
So this dB will become mu naught I ये 2dl में एक साथ लिखता हूँ, 2dl अपॉन 4 पाई r cube into r square into r is r cube.
Yes, sir.
Just copy this one.
Done, sir.
Okay, this is capital R, this is X, this is R. They form right angle triangle. R is hypotenuse. So R square is capital R square plus X square. I think you all know this Pythagoras theorem. This must be your knowing, no?
Yes, sir.
So if I take square root on both sides, then this will become whole thing raised to 1 by 2. When I take cube, then it will become R square plus X square raised to 3 by 2. That means now I can say EB is mu naught I into 2dl into R upon 4 pi R cube is R square plus X square raised to 3 by 2. Okay? That is explanatory, na? Followed or not?
Yes, sir.
Yes, sir.
Copy.
Done, sir.
I have told you tomorrow 9:15 onwards, na? 8 o'clock.
9:15.
9:15.
9:15.
Okay, okay. Just I'm writing in my book so that I should not miss anything.
Sir,
Huh?
sir, can we have tomorrow's class at 10,
10?
10:50, 10 o'clock, teacher?
नहीं मुझे चलेगा, देखो आप लोग को चलेगा क्या,
हाँ चलेगा.
बट बाकी बच्चों को चलेगा क्या, सबको चलेगा 10 बजे, तो मुझे कोई प्रॉब्लम नहीं है. 10 बजे कर दूं, चलो 10 to 11. Now we got dB, but we are interested in total B. So I can say therefore resultant magnetic field due to coil, not due to elemental length, but coil, comma B will be integration of dB, which is mu naught upon 4 pi I into 2 dl r upon r square plus x square raised to 3 by 2. Now, whichever constant quantity is present, I will take outside the integration. Mu naught upon 4 pi I into r square plus x square raised to 3 by 2, all are constant. Fixed thing. Integration of 2dl is not constant. Now, why I took 2dl? This time I took dB due to that upper half and lower half, because each were giving mirror image at one point. अगर इधर लिया तो इधर भी मिरर इमेज आएगा, इसका ये मिरर इमेज, तो एक साथ दो को ऐड किया हम लोगों ने, दोनों मिरर इमेज. तो dl means 2dl. Same way if I take here, this is dl 2dl, so this time 2dl 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 2dl, if I add throughout, circumference होएगा ये. Hello? But integration of 2dl will become 2 pi r, which is circumference of coil. Circumference of coil. Now we can say therefore B equals to. Okay, just copy this one, then B equals to. It's raining very heavily, don't go out anywhere. Nija, those two problems, doubt cleared? 151, 153?
Yes, sir.
151 डाउट होगा शायद ना.
Yes, sir.
तो लेंथ मतलब रेजिस्टेंस के जैसा ले सकते हैं ना, बिकॉज रेजिस्टेंस इज डायरेक्टली प्रोपोर्शनल टू लेंथ.
Yes, sir. Understood.
दैट्स व्हाई आई टुक टू पैरेलल, एक दो सीरीज एक पैरेलल होएगा हमेशा.
Yes, sir.
चलो प्लीज राइट टिल दिस.
Done, sir.
So therefore, P will become mu naught I upon 4 pi r. This is r square plus x square raised to 3 by 2 into circumference 2 pi r. 2 pi into 2 cancel. So mu naught I r square upon 2 times r square plus x square raised to 3 by 2. For n turns of coil, B equals to mu naught Ni upon 2 r square upon r square plus x square raised to 3 by 2. So this is expression for magnetic field at any point on the axis of circular coil. Copy. Now till this. So just read 2 minutes from start to end this chapter, right from Oersted experiment, Biot-Savart's law, right hand thumb rule, and two derivation. Anywhere doubt comes, ask. I'm waiting for 5 minutes for you all. Because next we have to take for straight conductor. Yes, read everything. Any doubt is there till this? Hello, any doubt till this?
No, sir. No, sir.
Start से ये देखते हैं क्या लिखा है heading? Derive expression for magnetic field due to finite current carrying straight wire. So we have in syllabus circular coil and straight wire. Coil का center, coil का axis, ऐसा straight wire can be finite, infinite or semi-infinite. So consider a finite straight wire AB carrying current I as shown in the figure. We want magnetic induction due to this straight coil. Let P be a point at a distance R near the conductor. E is a point at distance R near the conductor. See, I know only Biot-Savart's law. That gives me answer for elemental length. Then we integrate. So here we'll took small elemental length. Suppose this is point O. Let dl be the elemental length at distance L from O. Consider a finite straight wire AB carrying current I as shown in the figure. Let P be a point at distance A near the conductor. DL be the elemental length at distance L from O. Join DL and P. Let this distance be R. Angle made by DL and line joining P. DL and line joining P. This angle is actually theta. Hello? Hello?
Yes, sir.
Yes, sir.
So if I take this as 90 minus theta, then this will be theta or not?
Yes, sir.
Okay. अभी मुझे इंटीग्रेट किधर से किधर करना है, इधर से लेके इधर तक ना. So whatever answer I get, I want that length from B to A. So if P is here, then there will be some angle made by DL and this. P is here, there will be some angle. So we are calling this upper angle as phi 1 and lower angle this total as phi 2. Please draw the diagram. Diagram everybody has followed. This is finite conductor, P is point, DL is elemental length. This angle we took 90 minus theta. This is theta. फिर ये upper lower joint किया. ये angle phi 1, ये angle phi 2. Draw diagram.
Done, sir.
All derivation is from Biot-Savart's law, then integrating.
Done, sir.
Yes, yes. One second. One second. Now, first explanation of this diagram, then derivation will start. Consider a finite straight conductor. You can say conductor wire one and the same. Consider a finite state conductor AB carrying current I as shown in the figure. Let P be a point at distance A near conductor. Let dl be the elemental length at distance L from O. A distance L from O. Let angle between DL and line joining P be 90 minus theta. We have not taken theta this time. We have taken 90 minus theta. तो sin theta के जगह पे sin 90 minus theta लिखेंगे हम लोग. Please copy this much. Consider finite state conductor AB carrying current I as shown in figure. Let P be a point at distance A near conductor. Let DL be the elemental length at distance L from O. Let angle between DL and line joining P be 90 minus theta. Yes, completed.
Sir.
So we got point, we got DL, we got angle between DL and line joining P. Now we can use Biot-Savart's law. According to Biot-Savart law, dB equals to mu naught IDL sine DL bit P का बीच में angle 90 minus theta upon 4 pi into R square. So dB equals to mu naught IDL cos theta upon 4 pi R square. Therefore, resultant field comma B is integration of dB. So this will be integration of mu naught upon 4 pi IDL cos theta upon R square. From lower angle minus phi 2 to upper angle plus phi 1. See, when you go in downward direction, then negative. When you go in upward direction, then we take positive. So from phi 2 to phi 1. So this, if you take reference axis, this is lower negative, upper positive. So our variation is in angle because P, this is making some angle. If I take here, it will make some other angle. If I take DL here, some other angle. Angle will be varying. So we took phi 2 to phi 1. Copy this much.
Done, sir.
Mu naught upon 4 pi IDL cos theta upon R square. Theta is my variable. So I can't have two variable in the equation because even R is variable. देखो ये point P DL है, ये R, DL इधर लिया R अलग, DL इधर लिया R अलग. So R and theta both are variable. So we have to convert into only one variable. That means R should be replaced by constant things. Can you see this diagram in your book properly? This is theta, this is L, this is R, this is A. Can you see this properly?
Yes, sir.
Yes.
What will be cos theta?
R by A.
Cos theta will be R by A by R. Na? ये hypotenuse.
Yes, sir.
Sorry, sir. A by R.
Cos theta is A by adjacent side upon hypotenuse, A by R. So from this R will become A upon cos theta.
Yes, sir.
What is tan theta? Opposite side L?
L by A.
L by A.
L by A. L by A, correct. Tan theta is L by A. L will become A tan theta. So can I say that means dl upon d theta will be A into sec square theta? So from this dl will be A sec square theta d theta. Now my variable dl comes in theta, variable r also comes in theta. So I can say therefore V is mu naught upon 4 pi I dl is A sec square theta d theta I dl into cos theta upon r square will become A square upon cos square theta. Okay, integrating from minus pi 2 to pi 1. Is this any doubt, difficulty in your mind? Yes, any doubt, difficulty till there?
No, sir.
No, sir.
Please copy this one. One upon cos square is sec square, so I read that, and then cancel sec square theta with and a with a square. So this will become mu naught upon 4 pi I upon A inside cos theta d theta from minus pi 2 to plus pi 1. That is mu naught I upon 4 pi A cos theta ka integration is sin theta, and limit of integration is minus pi 2 to pi 1. So this is mu naught I upon 4 pi A sin pi 1 minus of sin minus pi 2. that is mu naught I upon 4 pi a sine of phi 1 minus minus will become sine phi 2. Sine of minus theta is minus sine theta in trigonometry. Sine of minus theta is minus sine theta. Therefore, it became plus.
Done, sir.
Just read again 2 minutes. Any doubt comes, then ask me. This is difficult derivation. Now, based on this concept, I am doing few sums. You get idea now. Complete. Take 2 minutes. Just go through everything. Yes. Have you read full? Yes. Have you read full?
Yes, sir.
Okay. No. First, for infinite long wire. That means it is increasing from both sides, infinite long wire. Is the point here. At a distance A. Now, infinite long wire, that means this line when I join with this angle will go on increasing, go on increasing, go on increasing, go on increasing, go on increasing. कितना होएगा? एकदम infinite होएगा तो एक स्टेज आएगा, it will become 90 ना?
Yes.
Yes, sir.
So can I say for infinite long wire, this angles phi 1 and phi 2 will be 90 90. This is phi 1.
Yes.
Yes. So for infinite long wire, phi 1 equal to phi 2, it is 90. So B, which is mu naught I upon 4 pi A into sine 90 plus sine 90. What is sine 90? Is it 1?
1.
So sine 91, sine 91, 1 plus 1 will become 2. So I will get B as mu naught I upon 4 pi A into 2. This is mu naught I upon 2 pi A. Okay. So if it is infinite, then mu naught I upon 2 pi A. A is the distance from conductor. Right, first note. It's raining very heavily. Let's complete it. For infinite long wire, B is mu naught I upon 2 pi A. Hello, completed?
Yes, sir.
Second. For semi infinite wire. Semi infinite means it is in one side it is fixed, other side it is increasing. So if this is B, this is A, here it is increasing. This is conductor, this side it will be moving up, so this angle will become close to 90. That means here phi 1 is 90 and phi 2 will be 0, because with B it is making 0 angle. So B is mu naught I upon 4 pi A into sine 90 plus sine 0. What is sine 0?
0.
0. So this will become B equals to mu naught I upon 4 pi A. Copy.
Done, sir.
Now you know, and questions I am doing so that you get idea of application of this formula. First one is the finite conductor carrying current I equal to 2 ampere. P is the point at distance of 10 meter. It is making angle here 45 degree and with bottom 30 degree. Point B. Can you tell me how to get B? Formula mu naught I upon 4 pi
Sine
a.
phi 1 plus sine phi 1.
That is sine 45 plus sine 30. I'm right, Avan?
Yes, sir.
So mu naught into 2 upon 4 pi into 10 sine 45 1 upon root 2 sine 30 is half. Mu naught upon 4 pi means 10 raised to minus 7 upon 5. This will be 2 plus root 2 by cross multiplying 2 plus root 2 upon 2 root 2. So you can stop here.
Done, sir.
This is square conductor coil having side A carrying current I. In anti-clockwise direction. I want find field at P, magnetic field at P. P is center of the square coil. P is the center. All the current will give field in same direction or in opposite direction. All will give field in same direction or in different direction.
Same day.
Inward or outward. एंटी क्लॉकवाइज है तो आउटवर्ड आता है हमेशा, याद रखना। सी आउटवर्ड ही आएगा ना। टेक एनी साइड, राइट हैंड थंब रूल। इफ आई टेक वर्टिकल साइड ऑफ द राइट, so curled finger or palm is going on the right side. When you make it curve,
Outward, sir.
it will come outward. सबका outward. So can I say net field B is 4 times first लिया तो भी चलेगा, second लिया तो भी चलेगा, 4 है ना ऐसा wire. So 4 times B1. Can I write like this?
Yes, sir.
And direction will be where? Outward, na? Outwards. Okay. Now, can you tell me? You want angle. What is this angle? How much is this? This is square.
So-
हाँ बराबर बराबर कितना?
40.
45.
This side is also 45.
Yes, sir.
Can I say here phi 1 is same as phi 2, both are 45 degree? Now what will be this perpendicular distance from the conductor? Distance from conductor. From conductor. हाँ क्या बोला आपने? Hello? I'm calling it as R. What is distance from conductor? Yes, rightly you said. How much? A by 2 बराबर टोटल का हाफ हो जाएगा ना सेंटर से A by 2. Now our B1 will become mu naught I upon 4 pi distance A by 2 sin 45 plus sin 45. I think you are following till this. So 2 times mu naught I upon 4 pi A 1 upon root 2 plus 1 upon root 2. Any doubt?
Yes.
Okay. Please copy this much. Yes, completed.
Yes, sir.
Today we'll stop here. Homework, please stick to the planner. If you are sticking to the